I just wanted to give you a little rundown of this spreadsheet so you don't have to go through all the trouble of figuring it out. Right here we have our observed mineralization values, and this is the total inorganic nitrogen observed in the bags, and this is our model. So we have our observed and our predicted values, and you can see here in the model that it's dependent on, it's connected to time in days, and over here it's connected to the potentially available organic nitrogen and the first order rate constant K. And so these are the values that you optimize to change. I have it set up to, you can either maximize this value by manipulating these values, and this is a tricky little equation involving the residuals, or you can, oh, there's Danny.
Hi, Amber.
Or you can minimize the standard square error, which is the sum of the squared deviation. So let's do that. So what I do is I use Solver, and you can Solver is an add-in, and you can find that through File Options, Add-ins right here, and then you go here, you say go, and then you click Solver right there. So, alright, so let's use Solver. So I'm going to set the objective. It doesn't matter, you can do either. We'll just go here. This one you make big, and this one you make small. So let's go here. We'll set it to minimize, and we're going to do that by manipulating these cells here. So this is using the Marquardt iterative algorithm, and that's the built-in algorithm in Excel, and that's also the one that SAS uses. So what I'll do, so I have it set to where it asks me to continue at each iteration, so I can make sure that things don't get out of hand, which they do. They can if you just let it go forever. So there's the first iteration. You can see the line is starting to fit at a correlation coefficient of 83. And so you can continue that, and every time I continue, you can see this number is getting smaller, this number is getting bigger, this number gets smaller, this number gets bigger. Just continue doing that. You can see the model is fitting the observed values better. Just keep on, and I know because I've done this that it pretty much stops at 95%. So let me accept those changes. So there you go. Stanford and Smith model did fit the data here for 10 ton per acre with a control included. On the x-axis we have time, and then we have inorganic nitrogen on the y-axis. So yeah, feel free to snoop around this spreadsheet, take a look at it, but I feel pretty confident that this information is accurate. Alright, thanks for your help.